E equals the set of numbers beginning with 1, 5, 9, 13, 17, etc. until 497. Find the number of all possible ordered pairs AB, which can be created from the members of the set E, such that A is greater than B. All right, everybody, the answer here is C, 7,750. And this is actually a pretty fairly standard, straightforward solution, so pay attention here. So first off, what's the question? We want to find the number of possible values that could be created from the members of the set where A is greater than B. And we have this ordered pair here, AB. And so we just need to find all of the possibilities where A is greater than B. And that's it. And so first off, we need to figure out how many numbers we're dealing with. That's the very first thing we need to know, because if we're trying to figure out all the possibilities, well, we need to know how many numbers we can work with. And so I hope we can see that this is an arithmetic sequence, because there is a constant difference here, a common difference every time. All right. And so the formula for an arithmetic sequence, it is the nth term is equal to your first term plus n minus 1. So the number of the term that you're on minus 1 multiplied by that common difference. And so I can figure out how many terms we have because we know that, hey, look, our first term is 1. Our common difference is 4, like I just said right there. And our nth term, or our, that nth term that we're looking at, it's 497. We just need to know what number term that actually is. And so from here, what we can do is subtract 1 from both sides, giving us 496 equals 4 times n minus 1. I just rearranged this. That's all I did. No problem. And now we can divide both sides by 4 to receive, and that would be 124 equals n minus 1. And so you add 1 to get n equals 125. So we have 125 terms in that sequence. Now, why was that important? Well, it's important for us because of the following reason. Look at this. So when you're trying to find out all of the possibilities that you have, well, think about it like this. Every term that's following is greater than the one that was before it because we're adding 4 every time. So what you can say is that, hey, look, 497, that final term, or my 125th term, it's greater than the other 124. So it's greater than the first, second, third, all the way to the 124th. Every single one of those. So that would be 124 cases there. 124 ordered pairs to start off with. Because again, that's 1, it's greater than 2, then 3, then 4th, and the 5th, all the way to the 124th term. So right here we have 124 terms. Then if we go down to the 124th term, well, that's greater than the first, second, third, all the way up until the 123rd term, which would make 123 possible ordered pairs, because this could be A, and any one of these could be B. Do you see where I'm getting at now? This is going to go on and continue all the way down to the very first term. Because if you're starting with your second term, well, it's only greater than your first term. So only 1 term there. So all I'm doing is just showing you the pattern that we notice. Because to find all of the possible ordered pairs, we're adding 1 and 2 and 3 and 4 and 5 all the way up until 124. That's what we're doing. Again, that means that we are summing up from the very first term up until 124. We are summing up 1 all the way through 124. So there we are. And so the formula for this, to utilize this in the quickest manner, it's n multiplied by n plus 1 divided by 2, with n being the number of terms that you're summing up. So with that said, boom. And this is specific to this summation here. And so what that would give us is 124 multiplied by 125, all divided by 2. And once you grab your calculator and complete the calculation here, we receive 7,750. And so there we are, ladies and gentlemen. That's the answer. I hope this helps.